Hi, in this video, we're going to take a look at some basic troubleshooting static routes. Okay, so or networks fail for a variety of reasons. Failed interfaces, the provider, the other end drops the connections, links become saturated, oversaturated, too much congestion, misconfiguration, whatever the case may be. So we're going to take a look at 4 commands here, just very basics. Ping, traceroute, show IP route, or show IPv6 route for IPv6, and show IP interface brief, or IPv6 interface brief for IPv6 interfaces. Okay, first of all, the extended ping command. Typically, when we use a ping command, it sends out the ICMP echo request, and it's sending it to the destination IP address, that the address following the ping. But the source IP address is that of the egress interface, the exit interface of the ICMP echo request. But if we want to actually force it to be one of our other directly connected interface addresses, we can use the extended ping command by following the ping with the source and then the IP address of the directly connected interface. Okay. All right, so here it looks like things are working well. So there's our extended ping command. Okay. Traceroute is very useful to take a look at, well, what are the actual IP addresses of each router along the way? So traceroute to the 192.168.2.1 address shows that the first hop is 172.16.2.2, that of R2, and the second hop is 192.168.1.1, the incoming or ingress interface of R3 on the way to the destination address. Okay, looking at the routing tables. This is another very useful tool to be able to troubleshoot networks. It's very important when you do any of these commands, including any of these show commands, especially show IP route. Take a look at it, and is the information what you expect to see, and is it all correct? Your network needs to be predictable. You need to know what the traffic flow is going to be and what is going to happen if one path goes down, and what will happen, what will be the redundant path, what will be the backup path, how will the network converge, how will your dynamic routing protocol converge, or whatever the case might be. You don't want to just to do a bunch of configuration commands that you read in the book and then say, well, I got it, it's working, so I'm not sure what it's doing, but I know it works. Okay. How to do something is one thing, but how it works and why it's doing it, that's what's important. All right. So look at the routing table. Is there anything in there that you see that you shouldn't be seeing or that's incorrect? Or is there something that's not in there that you should be seeing? Okay, everything's looking good. Show IP interface brief or show IPv6 interface brief for IPv6. Okay. It shows us a quick look at our interfaces, in this case, the IPv4 addresses. Is everything up and up? So we see here for status and protocol, we want to see up and up. If it says administratively down, that means there's still a shutdown command on the interface. If the status or protocol is down, that means that either on a serial link, it may mean that the other end is not up. We might have some kind of layer 2 encapsulation problem, whatever. We have a problem if you don't see status protocol up and up. Okay, so here's a little troubleshooting example. We're going to ping that 192.168.2.1 from our source gig 00. And as we can see here, it failed. Okay. Now, if we've already done the show IP interface brief, all of our interfaces look like they're up. And let's say we've done the show IP route command. So we do have a route to 192.168.2.0 network, or 192.168.2.1, that is included in one of our routing entries. Okay. Well, we might want to do is do a trace route. What path is it taking to get there? And our routing table says, well, the path that it's taken looks like via 172.16.2.2, then to 172.16.2.1. And whoa, wait a minute here. Look at this. It's going to 2.2 and then 2.1 and 2.2 again, 2.1. If we look at it, it looks like we have a routing loop. We're sending it to R2 and it's sending it back to us. So we're sending it to R2, okay? All right, so it looks like the information in our routing table, this is what we wanted it to do, let's say. We want to send packets to this network via R2, and that's what our static route is, that we configured our static route to do so, but why is R2 sending it back to us? Let's take a look, go to R2. So if I do show IP route on R2, let's look at its routing table. I do see a static route there for the 192.168.2.0/24 network that we're trying to reach. But wait a minute, look at that next hop address in red there, 172.16.2.1. That's not looking good. That's sending it back to us. Okay. So I do show running config on R2. I'm piping it, so I only look at the IPv4 static routes. And yeah, it looks like that next hop address is not correct. It should be sending it to 192.168.2.1 or 1.1. So let's go ahead and first let's remove that bad static route. You never want to keep a static route that you're no longer using. Okay, you want to remove it from the route from the configuration. It doesn't matter if even if it has a higher administrative distance isn't being offered or whatever the case might be. If you're not using a static route, if it doesn't belong to be in your config, remove it. Especially if it's a bad config, because we're going to replace it, or we're going to add the correct static route. Now, this will not just overwrite what's there already. It would keep both of them in there, and you'd have some intermittent problems going on, which might even be harder to troubleshoot when there are intermittent issues. Okay, so now looks like we have the correct next hop IP address. Let's go ahead and verify that connectivity. Ah, there we go. We send the ping and it's all working now. Okay, so that was just a little basics of troubleshooting static routes.